Welcome and good evening. My name is Christina Mallis. I'm here from the New York Times, where I am the Director for Customer Care Technology. And I'm joined here by Ahmed, Brian, and Ash, who represent our expanded care team. And we are here today to talk to you about how we have used Amazon Connect to improve our customer care experience. So to start, I just want to ground you in what brought us here and why we even undertook this project. At the New York Times, the primary driver of our customer care mission is to reduce effort for our customers and make this an effortless, easy experience so people can enjoy our great product. So we'll take you through how we found that these services enabled us to do that. And from there, we'll talk about what we learned throughout the whole process. So to start, I'm going to tell you a little bit about our company. Hopefully you've heard of us. I think we're probably one of the older companies here at the conference. We, I believe, turned 168 this year. And our mission is to report the news without fear or favor. We seek truth and help our readers understand the world. And we now have 4.9 million subscribers, which is more than any point in our history, which is really exciting for us. And we have an ambitious goal to get to 10 million subscribers by 2025. So where does care fit into all of this? We are there when subscribers hit their toughest moments, when their paper doesn't show up, they can't log in. We're really here to just make sure everyone can read our content and enjoy without having any friction. So we ideally seek to neutralize any problems that may come into play, make people forget they ever had to talk to us, and get back to reading and interacting with our content. So care, let's talk about where care came from and where we've grown and how we've gotten here today. So our care team was initially built to support the New York Times print product, our newspaper, which we deliver across the country and throughout the world. Because of that, we really didn't have any care for digital products or experiences. It really was focused on traditional pick up the phone, call, figure out where your paper is model. Today, obviously, we have a massive digital audience, which is continuing to grow, so we've had to expand how we support the people and the readers that we interact with. So in addition to phone, which is still heavily preferred and used by our home delivery print newspaper subscribers, we also have email, we have live chat, and more recently we've expanded into SMS text. So what we do with all this is really try and bring all of these channels together to make sure we have a holistic understanding of our subscribers' experiences with us. And because we have expanded our channels so much, especially in recent years, that's really increased the need for us to actually make sure that these channels can talk to each other and integrate and give us that context without having to jump around and search in different systems to figure out what is happening, which if you're an agent on the phone with a customer, you really don't want to spend precious minutes figuring that out when they might be angry about something that's happened. So how do we actually do this, and how do we all work together to make this happen? I think it'll be helpful to give you a little context into how our team works together. So here you'll see how our two respective functional groups interact with each other. On the left here is the customer care operations team. So that is the frontline agents picking up the phone, answering live chats, and all the workforce and the training and knowledge management and QA that goes into that whole experience to make sure we're really delivering on the quality that the New York Times expects. And then on the right, you'll see the care platforms team. So that's product and engineering, represented by my fellow panelists here, as well as design, who actually build and maintain the technology we use to support what we're doing to solve customer problems. And my team, the care technology team, sits at the intersection of these two groups, basically making sure the two sides understand each other's respective goals, making sure product and engineering and design understand how we use all of our systems and what we need from them. And then on the other side, product and engineering and design are giving the operations side technology, best practices, and actually making sure the tools are the best for the job that we need them to do. So where does Amazon Connect fit into all of this? So we brought this cross-functional group together, operations, product, tech, design, to really dive into some of the biggest pain points and opportunities we saw in our existing multi-channel environment. And one big one, given that we still have a large home delivery print subscription base, which we are very proud of, especially in this digital age, we still have a lot of people who want to pick up the phone and talk to us. And we were missing something really important in that phone experience, which is CTI, CTI stands for Computer Telephony Integration, and it basically enables us to know who is calling us, hopefully why they're calling us, and actually connect what people are saying to us back to our CRM, or our Customer Relationship Management System. So we didn't have this before. If you called and talked to our IVR, our robo-voice, and then transferred over to an agent, it was like you were starting over again. You had to repeat information. You felt like we didn't know you at all, even if you'd called us every day for whatever reason, and that was obviously painful and effortful for customers. So to actually start with this, we decided to build out a proof of concept, which you'll hear more about in a moment, to see how we could make CTI work and really shift the experience for our agents and, of course, our customers. And this is how we got to Amazon Connect. And our proof of concept was built with an internal team, which we set up for exactly this type of use case. We have an internal care team called The Hive, which is kind of a testing ground for us. They sit right with us at the New York Times headquarters office. And it really allowed us to have this kind of controlled environment where we could understand what was working, really partner with them to build this experience and make sure it was what we needed it to be before we rolled it out to our larger pool of agents. So now I'm going to pass you over to Ahmed, who's going to talk more about the proof of concept.
Okay. Thanks, Christina. Hello, everyone. My name is Ahmed. In the next few minutes, I will walk you through the story of how we used Amazon Connect from prototype to production. So I will walk you through the process, what problems we faced, and how we solved it. First question, why we chose Amazon Connect? First was ease of integration. Out of the box, Amazon Connect provides us with a variety of built-in features that can get the contact center up and running easily. Also provides APIs and SDKs that allowed us to integrate easily with our systems and other services. Regarding to scalability and reliability, we didn't have to spend much time optimizing running the service because we are getting it platform as a service, so we can focus on the features that we want to deliver to our customer while getting the same level of resiliency as other AWS services. And as typical for any project, cost is an important factor. So we didn't have to pay an upfront cost to start our prototype or start using the service. It's using the pay-as-you-go model, so we don't need any commitment. With all of that in mind, we thought okay, Amazon Connect would be a great fit for us to build our customer service experience on. But in addition to these factors as well, it's not only about Amazon Connect. It's about the surrounding ecosystem of Amazon Connect. So we don't need to build custom integration around it. There's a lot of other AWS services that we can integrate with. Here are some features we have and services we have foreseen potential integration with. Getting to the contact flow engine, think about it customer is calling in, so we have to get some customer information or we do input validation. So we can use Lambda for this. It's serverless compute service that can help us with that. Also, we need to save some information through the call. So we can use DynamoDB for that. It's a NoSQL data store service. Moving to AI services, when a customer is calling, we have to gather some information from the customer. So we need some kind of service to ask the customer about something or gather inputs from the customer. So we can use Lex for this and leverage the natural understanding language for that. Also, when you ask for something, you have to reply back or you have to play a specific prompt. So we can leverage the text-to-speech service, Amazon Volley, for that. Moving to data and monitoring, it's really important to dive deep into details and understand what's going on in your operation. So Amazon Connect already provides some integration with CloudWatch that can show us what's happening and all of the details about this. And there's different type of events we're going to talk about later, which we can already pipe to Amazon Kinesis and process and stream all of this information. Out of the box, Amazon Connect provides call recording. And if you choose to enable that, you easily can just save all of the WAV files to S3, which is a simple storage service. And we have sound files. So let's go through and we need this in text format. We can use Amazon Transcribe to do this. So we already went through like some of the basics. Let's go through some of the building blocks to how to get your contact center up and running. First, you have to deploy an Amazon Connect instance, and we have to go through some configuration steps. First, we have to go through identity management. Are we choosing to store user information into Amazon Connect directly? Do we have to use existing directory? Do we already use AD, Active Directory, or want to use SAML? Whatever option you choose, like you're gonna bake an admin, or like you can skip this option and configure it later on. When it comes to telephony options, there's inbound calls, and you can also do outbound calls if you want. And then comes to data storage. Here's like where you can enable call recording, like specify which log streams that your log's going for. After you do all of these steps, instance will take a few minutes to get up and running, and there's additional like stuff we have to configure. So customer is calling, so we need to have a phone number or different phone numbers. So there's a bunch of options here. So you can choose between different countries, and also you have the option to bake toll-free or direct numbers. Also, if you are already running like a contact center, you might have numbers in place. So you can easily import these numbers into Amazon Connect. And when you specify a number, you have to specify an entry call flow for that. So when the customer is calling, so they will get redirected to this entry flow. Then queues. So we have different sets of expertise, so we have to distinguish between them. So for example, technical issues, billing, so we can leverage the queues to do this. And here are a few examples how we built our queues. So you have agents and you have queues, and now you want to say, okay, like this agent can respond to calls from one or more queue. So with routing profile, we can specify that. We can just add one or more queue. We also can specify the priority for these queues, and also like enable or disable channel per queue. And here's like the main component of Amazon Connect, where you specify all of your logic here. So at this point, you say, okay, like we have to integrate with a backend service. We need to set some contact attributes, or like we need to get some metrics around this. And we'll go through some of this later on. Now, we already walked through how to get the contact center up and running. But in our case, like, okay, we need to run a POC, and like we can't left and shift what we have into Amazon Connect directly. We need to build a solution iteratively. So we can't do this in one step. So we decided, okay, let's integrate this with our existing IVR and see how this is gonna go. So we did this solution, and first, customer will call as usual to the existing IVR. They will try to get the request fulfilled. The IVR will call our CRM, will try to identify the customer, make sure like we know what the customer needs. At this point, we didn't change anything. So everything business as usual up to this point. But comes here to this point where, okay, like the request failed. We can't like respond to the customer at this point, and we need to transfer them to an agent. At this point, we are like, okay, making a phone transfer to Amazon Connect. But at this point, we already lost all of the information. Call coming from a different number, so we don't know who's that. And to solve this, once we enter the call flow, like we invoke a Lambda function, and this Lambda function will make a call to the IVR vendor, so we get all of the available information. We get the caller phone number, we get like, why is he calling about, all of the available information that happens through the IVR interaction. Once we have this information back, okay, we will set this to contact attributes. And contact attributes are key value pairs in Amazon Connect that allows us to set small pieces of information to each call. At this point, we already have all of the information available in Amazon Connect. So when we pass the call to an agent, so they already know which agent, if they already identified, all of this information would be available to them. And here's like what we implemented through our POC. So as you can see on the screens, here's a soft phone embedded into our web application. And here's a CTI section. And we already implemented this using the Amazon Connect Streams API, which is a JavaScript SDK that Amazon Connect provides. And like, here we can easily identify the customer, and if they are already identified, we'll show their account automatically. Also, we'll show why I'm calling about and other functionality. So we have seen that we can leverage this through our POC, and this took us like about 1 sprint, 2 weeks. So we've seen potential to integrate with Amazon Connect and move forward. So as Christina mentioned, we put this in production for like about a few weeks to make sure like, okay, everyone is comfortable with, and like we have to see metrics, we have to see is this gonna improve our process or not. And then we seen improvement because like right now we can easily identify the customer. So when they call in, so we know already. So imagine like you as a customer, you're calling an IVR, and then you already specify all of your information, and then like an agent picks a call up, and like you have to repeat all of that again. So this is not gonna happen again. It's gonna happen, but not every time. Sometimes stuff fails. So, and this also, the average handle time has been decreased in relation to this. So okay, like we're moving in the right directions, everything's good. Let's add more features to it. So we kept adding more features. So we are rolling by feature base. So when we develop a feature, we are running stuff iteratively. So we're going through that. Let's start with dynamic routing. So we have like, okay, we do have different type of customers. So we need to identify them and like direct them to different queues. And like we'll talk about this in details later in the session. Call transcription, as I mentioned earlier, we have WAV files already recorded. So we need to transcribe them and add them to our CRM. Oh, callbacks. So when it comes to callbacks, like it's easily like, okay, I'm calling and I'm on the line. I don't want to wait like about 15 minutes. So when agent is available, I will give you a call back as a system. So the system will just do a callback. And this is already like out of the box in Amazon Connect. We just have to incorporate this into our messaging to the customer. Positioning queue, it's very important for the customer to know where they are in the queue. So like, if I'm fifth in line, I have to know like I'm fifth in line. So I have to decide what's my option. Should I like do a callback, or should I just stay on the line, or like if there's any available other channels that I can go through. And call linking, we just get the calls from Amazon Connect and like just try to link them back to our CRM so we have 360 view of what's going on. So with all of these features we talk about, let's dive a little bit deep into the call transcription and see how we implemented that, because it helped us going through the process and just have more visibility in our calls. Okay, so Amazon Connect already out of the box records the calls and saves this to S3. So S3 has this feature which is S3 notifications, you can specify. So when a file is created, there's a notification will be embedded. So we leverage this, and when a new recording file will be created, we'll invoke a Lambda function. Lambda function will just start transcribe job. Once this transcribe job is done, we'll save the output to S3. And using the same approach of S3 notification, we'll take the output file and just invoke another Lambda function. Once we have this, we'll save all of this information to our CRM. So we have like all of the information available, and this was our initial implementation for the call transcription. You have seen a bunch of Lambda around, so like we need to set some rules, like we need to know how this is gonna work, we need to just build some tooling around, we need to make our process easier. So Go, our team has been trending using Go, so we built some other backend services, and we saw like the low memory footprint around the service. So it was like, wasn't a tough choice to use Go for Lambdas. Automation. So when it comes to automation, we are talking about like, if we have like few Lambdas, that would be fine to manage them through the CLI. But when you grow and like you have a lot of them, it would be challenging just to do everything through the CLI. So we have to build some tooling around this, and it was through the AWS SDK for Go and the SAM template, so we built tooling around that to help us with the development process. And to make this deployment process easier, we just like developed some practices around this, just making like once new code introduced to our version control, like team gonna get it reviewed, and then like build our functions, assign the specific releases, and just make everything in production ready after the health check pass. So all of this was building stuff. So let's say, okay, I built all of this stuff. Now I have to monitor and make sure my system run effectively and I know what's going on. When it comes to data, like CEO of LinkedIn, Jeff Warner, said, data really powers everything that we do. Data is really important, so it shows us, like, if we have a baseline, we can understand where we're going. If we are going in the right direction, wrong, we can solve problems easily and effectively. Amazon Connect already provide like different type of data, so we'll start with a couple of reports. So there's a real-time metrics. We'll show you information about like how many customers in the queue, like how many agents are available right now, if there's like a high call volume or something like this. Historical metrics shows the same stuff, but like in previous activities or past time. And like these information already available in the UI, in the console, so you can just use them immediately. But also the nice thing about this, they expose all of this information in the API. So you can leverage this through your contact flows or if you want to build customer integration around this. And when it comes to raw data, sometimes you might want to build your customer integration. You have specific business logics that you want to build. So Amazon Connect already provides some pieces of information. Contact flow logs, getting used through like specific pieces and specific blocks, so you can dive into deeper details. When it comes to contact trace records, it's easily like you can see the full picture of what happened through the entire call. You can know what phone number, queue, all of that kind of stuff. Agent event streams, similar to the contact trace record, but for the agent, you can see agent log in, log out, all of this information. So we have to build something that allows us to, okay, we need to run a business baseline, so we need to understand, okay, where is the problem, if there's a problem, and how we can solve it. So we built something specific to our use case. So first, we leverage the data we can get from Amazon Connect. First two already contact trace record and agent events going to Kinesis, and this is easily from the console. And then contact flow logs already going through CloudWatch. What we did is just like stream this to Amazon Kinesis. And then we talked about Lambda. We have a lot of them. So we do have the logs going to CloudWatch. We use the same approach and like stream this to Kinesis as well. Now we just built another Lambda function that we can consume all of these Kinesis events and just pass them to our data warehouse. At this point, we do have already all of our data aggregated in one place. So we can just build our dashboards and run a baseline and understand if there's a problem and solve it and just build efficient solutions. So at this point, we already like rolled Amazon Connect across our contact center. So we successfully rolled it out. So we were thinking about, okay, what's next? So it was like the right choice to make the IVR the next step, and we'll hand it off to Brian to talk about this.
Thanks, Ahmed. So my name is Brian Peterson. I'm a product manager on the Care Platforms team at the New York Times. And I'm here to talk about how we planned a successful IVR migration from a third-party IVR to one that we built in Amazon Connect. And so Ahmed touched on it briefly, but for those of you who don't know, an IVR stands for Interactive Voice Response. It's exactly what you expect to hear if you call any 1-800 number, press 1 for this, press 2 for that. It's that sort of thing. They're pretty much universally disliked, and our customers were no exception to that rule. But we saw a lot of our customers were no exception to that rule, which is why ever since I started working at the Times, people both on the team and external to the team came to me all the time with ideas for ways we could improve the IVR, reduce customer effort, reduce costs. And I had to say no to every single one of them, like a very stereotypical product manager. And that's because we had a third-party IVR. It meant it was difficult to build in it, it was expensive, and it was really tedious to work on. And so I had to say no to everything. And when a major new initiative at the New York Times would have required us to build and make changes in that IVR, rather than seeing it as a negative, we saw it as an opportunity to move forward with migrating to Amazon Connect and building it ourselves. And since we did that, I don't have to say no to those things anymore. So let's go into some more details. So like I said, there was a lot of value in migrating to no IVR, ownership, costs, and just the great agility gains we would get from owning it ourselves. But like any big project like this, there were a lot of barriers to progress. As a team that works on products for customer support, we have to be very reactive to changes outside the organization and inside the organization. And so there's always a lot of competing priorities from outside the team. There was also a really enormous feature list in the existing system, and making any change to a customer-facing flow is always going to be an enormous risk to operations if something were to go wrong. And that can affect both our distribution side of things with home delivery of the paper, or just our call center operations. So with that large project, this is one of those projects that was unstoppable. It was going to get done come hell or high water. And we found a way to basically pair the IVR migration up with that project support. And so completing the project in the old IVR would have taken a lot of time for our team just for this one feature to be delivered, whereas we could have spent a little more time, get a whole new IVR out of it, and support that bigger project. And so kind of sticking these two things together made it so that anyone who wanted to say no to the IVR migration was in effect saying no to this big company-wide initiative, which was basically impossible. So we were able to kind of clear a path for this thing in our roadmap. So when we first started talking about migrating the IVR, I had a meeting with someone on the care technology team who knew the most about the old IVR. And he walked me through every single flow in this thing. Subscriber identification for every different type of subscriber, deep multi-level touch-tone menus, a huge amount of self-service options, some of which were all about handling business like really rare business edge cases. And there were a lot of channel mismatches where we questioned why this was even in the IVR in the first place, when it was really a lot more effort to complete it there than in just talking to an agent or doing it in a self-serve flow online. So it helped to really think about what are the things our IVR actually needs to do. It needs to identify callers so that our agents don't need to spend their time doing that. It needs to route calls to the right groups of agents so that the person who answers the phone has the skills needed to solve the problem. And we also wanted to provide self-service flows as well in order to reduce the amount of volume going to our call centers. But with that huge number of different options in the old one, we had to really just focus on the most common issues. And so what helped a lot was that it pretty much fell right into the 80-20 rule principle, where the top 2 requests out of 10 were way higher in frequency than all the other requests combined. So looking at it in this way, it made it pretty easy for us to say, we want to focus on just these 2, and any other one of these requests will have to be handled by an agent. And it could even be less effort to handle it by an agent, depending on the flow. So with that, it was really important to get and keep stakeholder buy-in with a big project like this. We had to be honest about the risks and not just the rewards that we were getting out of it. So letting the care operations side know, you're going to see increased traffic. That was really important to get their buy-in to say, look, we can commit to making improvements post-launch. We will have some fallback strategies in place in case anything goes wrong. We didn't need to use them, but it was very comforting to have them for everyone. It was also important to commit to outcomes, not just features. Rather than checking boxes off in a huge feature list, our goals were to reduce customer effort, reduce costs, and increase our agility. And we could pretty easily track metrics for those to prove that we met our goals. And it was also important to over-communicate the amount of uncertainty that's involved in a large migration like this, especially when you're taking something that's customer-focused and moving it to a completely different channel. Even if you think it's the same, customers are going to do things that are unpredictable, and making sure that everyone who was affected by the IVR change knew that there was going to be a period of unpredictability. That was really important so that nobody was surprised by a big change. So I'm going to turn it over now to Ash to talk about how we actually built that new IVR.
Thanks, Brian. Hi, everyone. My name's Ash. I'm an engineer on the Care Platforms team at the New York Times. Today, I'll be sharing some insights into the development process for building a production-ready IVR. So in particular, I'll walk you guys through 2 features that we built for the IVR and talk a little bit about some of the challenges that we encountered, as well as the lessons that we learned along the way. Before we begin, I'd like to reiterate some of the points that Brian made, because I think they're really important. Before we embarked on our journey for building our own IVR, we wanted to define a set of principles that would really help us understand what this IVR should do, what the user experience should be, and also how we should build it. To that end, our team asked ourselves, what do we want to achieve for our customers and end users? In our care organization, our goal is to create an effortless experience for our customers to resolve their issues. Now, that can mean a lot of things. For us, that means that the experiences that we build need to be quick. Research from Gartner has actually found that customers prefer to have their issues resolved faster over using their preferred contact channel. So it's important for us to really manage our customers' expectations and make sure we can get them to the most efficient flow to save them some time. We also need the experiences that we build to be contextual. One of the common complaints that we had before we launched CTI was that customers would have to repeat information to an agent that they had already provided to an IVR. Now, that could be a really frustrating experience, and it effectively wastes the customer time again. So we want to make sure that anytime a customer provides us input, we carry that on into the experience and downstream systems and to an agent so that we never lose that information. Last but not least, we also want the experiences that we build to be intuitive. The previous IVR vendor that we came out from had a very complicated IVR tree. It had a lot of features, but it was way too complex for anyone to really use it. It was just too intimidating. So we need to find the right balance between usefulness and simplicity. So these are some of the principles that really helped us understand how we were going to design the IVR. But we also needed to ask our development team, what is it that we want to achieve within our own team? What are our goals and principles? Those are really going to shape how we pursue building products. So in our development team, we want to build, test, and ship also effortlessly. And for us, that means the solutions that we build need to be iterative. We want to establish quick feedback loops early in the process so that we can learn from our customers and adjust accordingly. We don't want to spend a lot of time building up a ton of features and functionality only to realize that we built the wrong thing for our customers. So that's really important for us. The solutions that we build also need to be reusable. Now, that's not to say that there isn't a fair amount of customization that you need to do to work with any new platform or technology. There always will be. But in general, we should be trending towards building our capabilities in-house and making sure that we can kind of share that across our care channels and even further than that. And also, we want to use tools that are simple. That really empowers our team to build products and features quickly, iterate, and learn in a iterative way. So all these principles, we found that having worked with Amazon Connect for the past year, we were able to really reinforce a lot of these. And that fit has really been the biggest win for us in terms of integrating with Amazon Connect. So let's just dive right into the tech. One of the first features that we built for our IVR was caller intent routing. If we can identify why a customer is calling as early as possible in the interaction, we can most effectively figure out where to send them. Like, should they be routed to an agent that's skilled to handle their issues, or should they be handled by a self-service flow that's designed for that particular need? So let's say we have a few categories. In our case, we have things like technical issue. Paper delivery issues are one of our common ones. The newspapers are still delivered. There's billing questions, there's cancellation, right? So the goal of the IVR is to accept some input in a very free-form way and categorize it into one of these. If we can figure out the category, it gives us the first step into figuring out what to do with that call. So let's say the IVR prompts the user, how can I assist you today? And the customer may respond with, I think I got my paper delivered today. That's a common one. What we want the IVR to do is automatically assign the input to the category paper delivery and use that information throughout the call to make decisions dynamically. So how can we build something like this? Well, Amazon Connect can certainly do this, but we're going to introduce another technology called Amazon Lex, which nicely integrates with Connect. And I'll show you how that's set up. So Ahmed had already mentioned what Amazon Lex does. It's a natural language understanding service, and it's used to create conversational bots. These bots are typically designed to fulfill a specific action on behalf of a user. The easiest way to set up a Lex bot is through the Amazon Lex UI, or the console. And in a few steps, you'll have a bot created. The first thing you'll want to do after your bot's created is set up your list of intents. An intent is essentially just a category or like an action that the customer is trying to perform. If you look at our call routing bot example, all the intents really correspond to categories that describe the nature of why someone is calling. And in bold, you can see we have one intent called routing delivery complaint. OK, great. So we have an intent. How do you match input to an intent? That's where the sample utterances come into play. An utterance is essentially just a keyword or phrase that maps to an intent. And for our routing delivery complaint, we have things like missing, never showed up. These are things that we add as time goes on, as we learn how customers are actually interacting with our system. And we'll talk a little bit about that later, too. So once we know an intent, and once we have input that can be mapped to intent based on these utterances, there's still a little bit of work left to do. We need to know specifically in Amazon Connect which queue or contact flow to route the call into. So it's a little bit of business logic, and that's where Lambda comes into play. Lambda can be introduced into your Amazon Lex bot in one of two ways. The first way is the dialog code hook. Now this means that the Lambda is going to be run at every step of the interaction. So anytime the user says something, the Lambda is going to get invoked. The second way is to introduce it as a fulfillment code hook, which is going to run at the end of the transaction usually, or the end of the interaction. Our team typically likes to introduce Lambdas as dialog code hooks because it gives us the greatest amount of flexibility. And we can kind of do the same things that a fulfillment code hook could. We can process the transaction and end it as well. So what is this Lambda function going to look like? What does it need to handle? What are some of the data structures that it needs to deal with? Let's take a look at that. So let's say when Amazon Lex invokes a Lambda function, that there's an event structure that gets passed in. I'm not going to show you all of the pieces of that event structure, just the things that are relevant for this example. So one piece that we get is the invocation source. This tells the Lambda function how Lex invoked it. In this case, it's a dialog code hook. It could have been a fulfillment code hook. We also get session attributes. Session attributes are essentially the state of your Lex bot. They're a key value pair, string, key value pair. And you can even initialize the session attributes before the Lex bot even prompts the user for something. So you can set up things like customer type, account numbers, basically give the bot some information about who it's interacting with so it can do some pretty smart stuff. And we also get the current intent that's matched. That's important for us because we need to know what intent was matched based on some user input so we can figure out what queue or flow to route them to. So we have a data source internally that manages this configuration. It's based on customer information as well as the current intent. And once we look it up in our data source, we're able to return to Lex a response structure that tells it what to do. So in this case, we populate session attributes that contain the queue ID as well as the contact flow ID. We're using the ARNs in this case because they're Amazon resource names. That's how we uniquely identify everything. We can also introduce other things like exit points to give agents some more context about what's happening in a more human readable way as well. And we also return a dialog action, which is, I'm going to get into that a little bit later, but it allows us to control the behavior of Lex ourselves. In this case, I'm using a dialog action of delegate, which basically tells Lex, just carry on, do what you normally do. I'm not going to tell you what to do. So how does this integrate with Amazon Connect? This is a contact flow builder, and the main entry point is the get customer input block. This allows us to accept user input from a user, I guess. You can set up a Lex bot here. So we're setting up the call routing bot. And we can also set up aliases here. That's really useful because That's literally the worst timing. So we can also set up some session attributes. In this case, we set up customer type. And we also have the list of intents that we can match on. And these serve as like nodes that we can kind of control the flow from. All of that kind of just feeds into another block called set contact attributes. So in the previous example, I showed you a Lambda that was returning some event structure with like session attributes. All of those can be pulled out in this block and stored on the contact attribute level. So that means any downstream system or reporting or even our agents will be able to get all that information, which is really powerful. And all the magic really happens here. We can set a working queue dynamically. That means the Lambda function that was returned by Lex can return a queue identifier, and we can set that queue dynamically. And likewise, we can do the same thing for the contact flow. Now, this contact flow can, depending on the configuration, decide to route that user to a dedicated self-service flow, or it could just be a flow that just simply routes that person to that queue that was dynamically assigned already. So that's basically how call routing worked. But like I mentioned, we have some self-service flows. So let's jump into the second feature we built, which was misdelivery reporting. We looked at our list of transactions, and one of the highest volumes, like I mentioned earlier, was people reporting that their paper didn't get delivered properly. And this is kind of simple because we only need to accept two things from them. So here's what the interaction looks like. The IVR is going to prompt the user, how can I assist you today? Customer says, didn't get my paper delivered. Except now, the IVR is going to apologize, and it's going to ask the customer what date they missed their paper. So we're starting to collect information from the user now, which we didn't do before. The user says today. They could have said yesterday or any specific day. And the IVR is going to look up some configuration based on that input, do some validation, and figure out that they can have their paper redelivered. And so it prompts them for that. The customer says, yes, I'll have it redelivered, and the IVR confirms it. It'll be redelivered in the afternoon. So this is slightly more complicated than just call routing. There's the introduction of inputs to our system that are just different from like the raw utterances. So we're going to introduce another concept in Lex for just doing that. So in our delivery complaint bot, you can see we set up an intent called missing paper. Pretty similar, has some utterances that it can detect on. But the most important part here are the slots. The slots are essentially pieces of information that we want to collect from the user. Now, slots can have different attributes like a priority, whether it's required or not, and different slot types. Slot types are the data types for a slot. And for issue date, for example, the date that the person missed their paper, we can use a built-in slot type called Amazon date. This can help parse different types of dates in all sorts of different formats, which is great. But for action, which is whether the person would like to get their paper redelivered or get credit, we wanted to have like an enumeration, because there's only two things they can do. So we created a custom slot type, which is the second data type here. A custom slot type can be restricted to a certain set of values. So in our case, we have a slot type for credit, slot type value for redelivery, and we set up some synonyms that allow the user to match on these things. Now we can also support touch tone, which is really important for us because we want the system to be like seamlessly accessible, meaning they can switch from touch tone input to voice-based input without really going through the effort of doing that. They should just be able to do it whenever. So we can add the numerical values of the keypad entries as synonyms. So if, in this case, we have one associated with redelivery, two associated with credit, and if they enter in the touchpad instead of saying it, we'll actually be able to match it on that, which is great. What does the Lambda look like for this now? It's going to be pretty similar. So let's say IVR prompts, when did you miss your paper? Customer says tomorrow. Well, they can't have missed it tomorrow, so that's going to be an error. What do we get back from Lex? Lex sends an event structure to Amazon Lambda with some slot data. Now, the goal for your Lambda, once you're in this state where you're trying to get user input and fulfill their requests, is you try to take data from the slots that by default be null, and you try to move them into your session attributes by validating them against whatever business logic you have or some backend services. So in this case, we get the slot data containing our issue date, which is December 3rd. We get some session attributes predefined from Amazon Connect that we set up earlier. So we'll have the account number of the user, and we have the current intent. So we're going to hit our backend services in this Lambda, combination of slots, session attributes, see that the validation failed, and we return a dialog action in this case. Now, before we returned delegate, here we're controlling the state. We're using a dialog action called elicit slot. Elicit slot allows us to ask the user to provide input for a slot, and it's a really cool tool for allowing us to control the user interaction. So if we want to move them, if we want to ask the user to enter some other piece of information, or if we want to reprompt them because there is a validation error, elicit slot is one of those dialog actions that really allow us to control what the customer hears and how they should respond. There's some other dialog actions that we needed to make this bot work. One of them is confirm intent. This allows us to prompt the user if what they're doing, or what we're doing is correct. We can do this at the very end of the transaction. But in general, when we build our own IVR flows, we like to confirm after getting every piece of input, just because it'd be kind of a pain to get to the end and realize there was an error. So it's just easier to confirm it every step of the way. And we can also use the close dialog action, which can be in either a fulfilled or failed state. And you can use this if you need to just like end the interaction because there's a validation error or your backend services were down. Typically, if we have a failure and our contact centers are open, we'll just tell the customer we'll transfer you to an agent because that's really how we can best serve them. So building Lex bots through the Amazon console is pretty easy. But once you have a larger team, it's really hard to track the changes, like who's making what change and synchronizing deployments and stuff. So likewise, how we did with Lambda functions, we decided to automate how we deploy our Lex bots. We do this by leveraging the Amazon Lex SDK. It's just Go code that we write that hits the SDK as well. And the first step is to import the bots. There's bot configuration that can be imported as JSON files. So this includes the bots, the intents that are related to those bots, and then the slot types that are related to those intents. So we just put all of that into our file system, commit that to version control. This way, all of our devs can see like what's being changed with each Lex bot. And then we have a deployment process that will run in our CI pipeline. Anytime code is merged in to master or tagged for release, we'll run this deployment script that will take the current configuration for that version of code, compare in Lex all the previous versions and see if there's any changes. And if there are changes, it'll basically deploy a new version. Once those versions are deployed, it'll wait for the bot to build. And then lastly, we'll alias the bot, which is necessary because we use the same bot for both staging and production. So we use aliases to really track which one's which. One of the common changes that we introduced through this deployment process is actually utterances, because when we first create a bot, we kind of only know what we would put into the system, like how we would say that we have an issue, but you really have to learn from user data. And once we get user data, we can adjust the utterances so that they match properly. So we wanted to automate this process as well. You can already see which utterances are missed in the Lex console, but what you can also do is set up a simple cron job in CloudWatch, runs daily, have a Lambda function that calls the get utterances view SDK in Amazon Lex. That'll pull in all those missed utterances. It's like a rolled up snapshot, but we store that into our databases so that we can actually track some trends in the utterances and the detections of it. So this is helpful for two reasons. One, we can easily see what the top utterances are like from day to day that we need to address. But also, it allows us to really easily figure out where to make the necessary changes and automate that as much as we can. So that's been really helpful for us for learning from our users how to basically make our bots better. So there's a lot of lessons and challenges that we encountered along the way in this process. I don't have enough time to talk about every single one, so I'll just summarize some of them. There are two. I'll bring up two challenges that we ran into. The first challenge is automated testing. I come from a team that knows how to write maybe end-to-end tests for a web application, but it's not as straightforward to figure out how to test a voice-based service. So that's an area that we're actively looking into figuring out, setting up some automated tests in our pipeline. That would just make it a lot more easier to understand when you're introducing some improper code changes, for example. The second challenge we ran into is that we couldn't find an easy way to deploy the contact flows. So we've had the opportunity of building a fully automated deploy pipeline for Lambdas and for our Lex bots. So we're really waiting on features for Amazon Connect to allow us to fully deploy our contact flows. And we'll reach a situation where we can actually fully automate getting contact flows, the Lex bots that are in those flows, and then the Lambdas that are in those Lex bots, always deployed, so we can move a lot quicker when that happens. In terms of lessons learned, log a lot of things as often as you can. Lex bots can seem like a little bit of a black box when you start working with it. And most of the time it works, but in the times where it doesn't work, it's hard to understand why that happened. So the easiest thing you can actually do is just set up a Lambda function on that Lex bot to just log the event structure that's coming into it. That way, as you collect data from your bot, you can actually just see in depth like what Lex is thinking people are saying and what it interpreted it as. And you can kind of figure out if you need to like change the slot type or create your own or just do whatever with it. But it's really necessary to have that information. And the second lesson is be creative. Like there's a lot of ways to implement the same thing in Amazon Connect and Lex. It's a platform that really gives you the flexibility of figuring out how to build things. And with that flexibility comes a lot of different approaches for solving problems. So I'd suggest if you're getting started with Lex or in Amazon Connect, or if you've already been working with it, continue to really experiment with it because you'll definitely find novel ways of doing something that is better than what you've had before. That constant learning process and improvements really made Amazon Lex and Connect a satisfying experience to work with. So I'm going to hand it back off to Christina for some closing thoughts. Thanks, everyone, for your time.
Thank you, Ash. So as you just heard, a lot of challenges and lessons learned along the way. So I'll just take us through some key takeaways from this entire endeavor across our cross-functional team. Number one, start small. As you saw at the beginning of our presentation here, starting with a proof of concept was really crucial for us. Replacing a major end-to-end contact flow is, as shown and as expected, no small feat. And having a contained pilot experience really enabled us to make sure it was going to be a success. It also allowed us to actually inform the design and build and implementation of what we were actually doing because we were working with a new set of services and we really needed to understand what we were working with to actually know how to build with it. It also allowed us to calibrate our actual success criteria and reporting needs because they were really changing from our legacy model. Takeaway number two, be flexible. As Brian talked about, we had a large company initiative that was kind of a mixed blessing. It actually allowed us to get this work off the ground, which was awesome, but it also at times competed for bandwidth with this project. So by really doing that evaluation of all the features that were in the previous experience and what was really needed, we had the information we needed to kind of make trade-offs and be flexible about what was being built when and what was really crucial for our launch period to make sure that we weren't completely blowing up the experience for our agents and for our customers with too much change all at once. Finally, communication. I know this sounds like an obvious one, but when you have so many different groups working on systems that affect so many people, from our customers to our agents to our workforce managers to our distribution team, it's really, really important that all those different players are talking and talking regularly to make sure that if there's crucial information we need to know at the start of the build of the feature, we actually learn that when it's not too late to actually do something about it. So I think, talking about the team structure, as we did earlier, really demonstrated how we were set up to make sure we were communicating regularly to make this successful. And it's also really informed how we're working moving forward, which is exciting. I think we learned a lot about how to work together effectively to inform large-scale initiatives we'll be taking on in the future. So with that, we'll wrap up. Here is our contact information. We'd love to hear from you if you have Amazon Connect feedback or questions or any other topics you'd like to discuss. And thank you so much for your time.